Hello everyone, I'm Dr. Daniel Barth with Astronomy for Educators, here with another exciting activity that you can do in your class. This week we're going to use a ball of clay, a small marble, and a flashlight to help your students learn how sunlight travels across the moon, how sunrise and sunset occurs, and what this has to do with lunar phases, and what we see when we look at the moon through a telescope. We're going to be switching the camera in a minute and going hands-on with our ball of clay activity, so stay tuned. All right, here we are with all our materials. As I said, this is very simple. We have about a 500-gram ball of clay. It can be smaller. This is about fist size. If we measure this, this comes out to be about, about 6 or 7 centimeters in diameter. And any color clay will do. I have gray here, and I've made it soft enough that I can roll into a smooth ball. If you're working with young children, I've actually had great success with putting balls of clay on a cookie sheet and setting them on a radiator for a few minutes. That warms them up. Otherwise, the children can just, squish and mold them until they can roll them into a smooth ball. I've got a 25 millimeter marble here, but any marble will do. And all we're going to do is we're going to start by taking the marble and kind of rocking it in, and ooh, we've made a lovely crater. We're going to make 2 or 3. Sometimes craters overlap on the moon, sometimes they're small, sometimes they're very large, and you don't have to make very much. So I've got a small craterscape here with 2 or 3 craters. Now I'm going to go to the bottom of my moon, and I'm just going to pinch a little piece of clay off. And at this point, I'm just going to take a very small amount of clay. You can see it's a little ball here, just a couple of millimeters wide. And I'm going to make a little mountain shape, and bang, I'm going to put a little mountain in the middle of my crater there. I'm also going to go ahead and put some other mountains, different places. Many craters have mountains. Some craters do not. Generally, it's only the biggest ones that have them. And sometimes we see mountains that are clustering around the edge of a very large crater, sometimes around a maria. And if you're interested in these sorts of things, you can take a look at my book, Astronomy for Educators. Put Astronomy for Educators, Daniel Barth into any search engine and it'll pop up for you. This book is made available for free as a free educational resource. It's published by the University of Arkansas Library Press, and anyone, teacher, parent, student, can download it if they wish. Now, what I'm going to do here is I'm going to take my cell phone and I'm going to turn on my flashlight. Now, this is going to be a little bit glary, but I think we'll get the idea. What we're doing here is we're holding our clay moon up, and we're going to move the flashlight around it. This works really well with partners. If you have students working in partners, particularly if everyone has a cell phone, one person can be moving while another person draws. You can also do this where students move the flashlight and then they sketch what they see. But what we notice here is that, we have this bright light section, brightly illuminated section, and the dark section. The line between the two is called the Terminator. This is the line that divides light from darkness when we see lunar phases. And as we move this up slowly, and I'm trying to make sure I'm getting the moon here in focus. There we go. We see how this line of brightness moves across the moon, and as we move up, oh look, the shadows recede out of the craters, and then as we go to the other side, the shadows come down in. I'm having a little trouble with this with the light and my camera, but you can get the idea that you can see this line of darkness move across the surface of the moon. There, that's working pretty well. And we're seeing how this moves across. The shadows fill the craters. You notice that one crater with the dark section and the point of light inside? That's actually a mountain tall enough to reach up out of the shadow and be brightly illuminated at its peak. You can actually see phenomenon with this, like this, with any small telescope, when you look at the moon and you focus along the dividing line, the Terminator that separates daylight from darkness. Essentially, when we see the lunar phases, what we're seeing, friends, is we're seeing a line of sunlight move across the surface of the moon, and then we're seeing a line of darkness come back the other way. And so what we're actually seeing when we run this experiment is we're seeing how lunar phases actually show us the line of sunlight crossing the moon. And if you think about the Earth, we know that the sun doesn't revolve around us, we revolve around the sun. But if my orange ball here is my marble, is my sun, and we know that what happens, the side facing the sun is illuminated, and as we are carried around the Earth, as the Earth rotates, what happens is we are brought into the daylight, we see sunrise, and then, we have full noon, the sun is overhead, and then the rotating Earth carries us away from the sunlight and into darkness once again. The same thing happens on the lunar surface, but what we see in phases, we're either seeing a line of sunrise sweep across the moon, that's during waxing moon when the moon's visible in the early evening and the shadow is actually moving from the east to the west, and then when the moon is waning after full moon, when the moon is visible in the early morning, we're seeing the shadow advance across the surface of the moon as the features rotate into darkness. Now, you might say, gee, this whole process takes almost 30 days. Yes, because the moon itself rotates very slowly. Unlike the Earth, which spins once per day, the moon only rotates on its axis once every 29 days, once a month. And so this very slow change in the lunar phases that we see is actually the very slow progression of the sun across the lunar sky. It's fascinating how rarely we see this idea of sunrise and sunset on the moon linked to the study of the lunar phases. It's a very simple idea and a powerful one. It helps your students see the moon as a place, as a world, not just as a thing up in the sky. My students recently did a search before class, learn everything you can about lunar phases. Not a single one came up with the idea that the lunar phases represents a line of sunrise and sunset sweeping across the moon. I hope this has been exciting for you. This works great in class. It also works excellently as a remote activity. Students who do watch the video and do the activity at home can take pictures of their little cratered moon surface and pictures with the flashlight. If you have students that don't have flashlights, if they're too young, for example, the little squeeze flashlights that go on keychains that you can get at the dollar store or on Amazon, those work great for this sort of an activity. And lots of fun, and it gets kids' hands and minds engaged, which is a very important thing. Well, there we are. Our lunar phase activity showing the action of the Terminator, the line between daylight and darkness as it sweeps across the moon as the phases changes, bringing sunrise and sunset to places on the moon. I hope you've enjoyed this. If you have questions, you're welcome to email me at astronomyforeducators@gmail.com. I hope you'll like this video, subscribe, and share it on your social media with your friends. Thank you, everyone. This is Dr. Daniel Barth, hoping I'll see you again on Astronomy for Educators.